Welcome back to Easy Driver, the most reliable source of automotive information on YouTube. In this segment, we'll build upon the foundational knowledge from Part 1 and explore advanced splicing techniques such as soldering and heat shrinking. Additionally, we'll discuss common issues that arise during splicing and how to troubleshoot them effectively, ensuring optimal performance and safety in your vehicle. Best practices for splicing automotive wires. When it comes to splicing automotive wires, understanding the best practices can make a significant difference in the overall performance and safety of your vehicle. By avoiding common mistakes and prioritizing electrical safety, you can ensure a successful and reliable connection that keeps your vehicle running smoothly. Avoiding common mistakes. One of the key aspects of achieving a successful wire splice is to avoid common mistakes that can lead to electrical issues down the line. Improperly stripping the wires can result in weak connections and potential short circuits. It's crucial to strip the wires carefully and ensure an adequate amount of exposed wire for a secure bond. Inadequate sealing is another common mistake that can compromise the integrity of the splice. Without proper sealing, moisture and contaminants can enter the connection, leading to corrosion and poor electrical conductivity. Always use the appropriate sealing materials to protect the splice from environmental factors. Using incorrect connectors is a mistake that can have serious consequences for the electrical system of your vehicle. Choosing connectors that are not compatible with the wire gauge or type can result in unreliable connections and potential overheating issues. Make sure to select connectors that are specifically designed for automotive applications to ensure a secure and durable splice. Ensuring electrical safety. Prioritizing electrical safety during the splicing process is paramount to prevent accidents and damage to your vehicle's electrical system. Before starting any splicing work, make sure to wear protective gear such as gloves and safety glasses to prevent injuries from sharp edges or electrical shocks. It's crucial to disconnect the battery before initiating any splicing to avoid accidental electrical discharge or short circuits. Double-checking the wiring diagrams before making any connections can help you identify the correct wires and prevent any mistakes that could have negative repercussions on the vehicle's electrical system. By following these best practices for splicing automotive wires, you can enhance the reliability and safety of your vehicle's electrical connections. Remember to prioritize proper insulation, strain relief, and thorough testing post-splicing to verify the connection and ensure optimal performance. Please drop a comment below, a thumbs up if it's hitting the spot, and don't forget to share with friends who might like this and hit that subscribe button for more. Let's continue. Testing and verification. Ensuring the reliability of spliced automotive wires is crucial in maintaining the electrical functionality of a vehicle. By conducting thorough testing and verification, you can prevent potential electrical malfunctions that may arise from faulty connections. Here's how you can perform testing to confirm proper connectivity and electrical continuity. Conducting resistance checks. When splicing automotive wires, it is essential to conduct resistance checks using a multimeter. Resistance checks help identify any short circuits or open circuits that could disrupt the flow of electricity. To perform this test, set your multimeter to the resistance mode and touch the probes across the spliced wires. A low resistance reading indicates a proper connection, while a high resistance reading signifies a faulty splice that needs attention. Voltage testing. Voltage testing is another critical step in verifying the integrity of spliced automotive wires. To conduct a voltage test, set your multimeter to the voltage mode appropriate for the system being tested. Carefully connect the multimeter probes to the spliced wires to measure the voltage levels. Ensure that the voltage readings match the specifications of the vehicle's electrical system. Any deviations from the expected voltage levels could indicate a faulty connection that requires further inspection and correction. By performing resistance checks and voltage testing on spliced automotive wires, you can confirm the presence of proper connectivity and electrical continuity. These verification steps help maintain the integrity of the vehicle's electrical system and prevent potential issues down the road. Remember, a thorough testing process is a key aspect of ensuring the reliability of spliced wires in automotive applications. In conclusion, mastering the art of splicing automotive wires is essential for ensuring the safety and efficiency of your vehicle's electrical system. By following proper techniques and using the right tools, you can avoid potential hazards such as shorts or faulty connections. Remember to always use the appropriate wire connectors and insulation materials to protect your splices from moisture and corrosion. Practice good wiring practices in all your automotive maintenance and repair tasks to maintain the integrity of your vehicle's electrical system. Stay safe, stay informed, and keep your automotive wiring in top-notch condition for a smooth and trouble-free driving experience. Happy splicing! That concludes part 2 of our ultimate guide to splicing automotive wires. We hope you found these insights valuable in your automotive endeavors. Remember, practice makes perfect when it comes to mastering wire splicing techniques. Stay tuned for more informative content and happy splicing. Please comment, like, share, and subscribe for more automotive information like this. Thank you for watching.